Listen, we're excited to be back at this conference. I think it's important to Dublin. Cronin did a phenomenal job last year. We felt like it filled a vacuum in this space almost immediately. And now, second year, it's as if it's always existed. I think it's an important forum for us to share what we're doing. And as you'll see, we're going to talk a bit about the how, probably much less about the what, and you'll see why. So, just in the form of introductions, Aon, I like to call us the Uber of insurance because that sexies it up. We are the largest commercial insurance broker, yet we don't issue a single policy. We help our clients to find the best policies to fit their needs. Anyone who's now paying 30 to 40% more for their auto insurance, I cannot help you, but I do sympathize with you because I got hit with the same bill here in Dublin, so sorry for that. We have in Dublin about 150 people, another group in Singapore. These are Aon's two analytics centers working on some of the most complex problems facing the firm. And we really are the answer to bringing analytics into, across the firm by first, centralizing, prioritizing, and working hard to create usable solutions for the analytics problems the firm faces. So with that in mind, today, what I can't talk about is specifically what we do. It's a competitive space, and there could be spies lurking. So what I can do instead, similarly to what we did last year, is talk about how we do it. Because I think, again, that's our obligation. It's our obligation to share it. It shows what our culture is all about, and it also exposes us to criticism and feedback. So we want to learn. We are but journeymen here, improving and honing our craft. So certainly this is, we'd like to talk about how we're doing things. Last year we talked about some of the traps in analytical processes and how to avoid them, putting time boxes in place, giving people imperfect answers quickly rather than having long drawn-out processes looking for 6 decimal places. Teaching people how to fish, so trying to reduce dependence on a scarce analytical resource. Stage gate, which was for us a way to stop some of the insanity of too many requests and not enough supply. And then agile. Agile for us has been watershed. We'll talk more about that today. It's really brought our team together in some surprising ways. So what I'd ask is, I guess I'll say that as I developed this talk, I really was torn a bit. I'm a computer scientist, I'm an analyst, I'm also a business leader. How do I put all these things together? How do I not go too nerdy to lose some of the business audience, because this is the business track, and how do I yet give some nerdiness to those of you out here like, oh, I don't want him talking about the high-level stuff. So what I've got is going to be sort of a business nerd, business Sambo. And we'll see how this works. I'm sure will give me feedback after the fact. But I think we've got enough kind of meat in the middle. And of course, since this is Dublin, there's absolutely no mayo in this. So sorry for the bad joke. What I'd say is if we take a good hard look at our analytical prowess and how we do what we do within our cultures, our analytical cultures. I'm going to indict myself on this as well. We're creatures of habit. We work historically on data extracts on our laptops. We create point solutions that don't scale, don't translate to production. They don't do both in many cases. And we don't share our code sometimes within these groups. We're very proprietary. We are very much like craftsmen protecting our secrets. And that it basically involves us creating point solutions to data problems. For us, that has been a real frustration and something that we've worked to eliminate. We now realize that for us to move faster, we have to build more data-aware applications, applications that are built understanding the production environment in which they can ultimately live and understanding the customer's needs down the road. So we'll talk a bit about moving faster in very integrative terms. And some of this will just require you to understand, hey, we integrate all of what we do. That is core to how we do what we do. But there will be some pro tips sprinkled through here in terms of things that I and the team think you ought to learn or take a good hard look at. things that can help you spend a lot less time in the doing. We will share with you 6 parts of our transition to faster. The first is from code, going from code to data-aware applications. The second, laptops to cloud. How many people here are doing all of their analytics work on cloud-based instances? 5 hands. How many people are doing all of their analytics work on laptops? About 20 hands, okay? That helps. And then the other folks, I'm going to assume that you're here for the bread part of the sandwich, and that's okay too. We're going to talk about moving from ETL to change data control, from databases to key value stores, and my favorite of those, Redis. If they were public, I'd say buy stock now. We're going to talk about persistent computing versus ephemeral, and you're going to hear me mention ephemeral several times, so I better define it now. Ephemeral is here for a moment, then gone. Servers that come together to solve a problem under an orchestration framework, and then they disappear, okay? We try very hard to move in this direction. You'll hear more about that. And then we have it down on the left, anything other than Agile Scrum moving to Agile Scrum. So that's what we're going to talk about. Code to data-aware applications. So if we look at the classic process of analysis, for a lot of people on the receiving end, this is like Christmas. Oh my gosh, you've given us a great answer. This is fantastic. But for us, we elves who do the work, there is a huge period of time called waiting for the data, another huge period of time called cleaning the data, then sometimes validating the data, which is basically code for you got to kick it back because you got the wrong data, or it's just horribly dirty, or you'll never get anything out of it. And these are all the preludes to that great epiphany, which is the time where we can analyze the data. Modeling there dropped its M, but that's what that tiny little phase is. And then the parts after that, packaging, explaining, revising. As Dr. Elder said just a few minutes ago, those are actually the really important bits. But for us, sometimes they're just a tack on, okay? Others feeling guilty as charged on this? Feeling similarly frustrated? What I would say is, as magical and perfect as the point solution you create through that process is, it ends up being but a bag at the airport. You've designed something that's sitting there amidst a complex data organization, and you ask yourself, well, why have I not taken the lap of honor? Why have they not closed the office? I solved this. This is fantastic. What we've discovered is that when you do that, and you develop something that is utterly detached from the data organization, there's no way really for us to integrate it. So that creates a huge bit of frustration. I had a couple of guys last year who had come to me nearly in tears saying, they've rewritten all my Python. They've added SQL to it. It's terrible. Well, what did you expect? You were working off an extract. You had no business writing something that couldn't live in a production environment, with all due respect. So, I say it more nicely, in this situation, just so you guys are worried about that. But as we think about, for us, the analytical process is really one from concept to customer. So the can it be done part is hugely important. And that's the role of a great analytics team. The next part, and the red arrows indicate that there is work to be done too often, too much. Work to be done to reshape that solution and make it fit in an engineering environment, a data airport, if you will. 737, 787s coming in, cleaning crews, fuel crews, baggage crews, all of those things happen at this unbelievably complex thing we call an airport. There's work required to take your perfect creation and move it there. Second is, there's further work to say, okay, this was great, and now we got it working. It's dealing with all the major databases, and it's in the orchestration framework. It'll happen asynchronously, blah, blah, blah. Great. But does it really meet users' needs? We're going to have to tweak it. And what frustrates me so much, for my analytical brethren, is that so often that loop comes back to the engineering side and doesn't come back in to the analytics side. We don't often get the call to say, hey, could you have actually looked a little more broadly or a little more deeply or changed the parameters of your algorithms? And so I think that's frustrating. Frustrating to people like me, frustrating to people as we've gone on this journey. Our goal really is to make sure this doesn't happen, that the solutions we put together in that analytical can it be done phase incorporate the complexity of the airport down the road. Okay? Next part, laptops to cloud. So that's why I asked earlier, you have this great bit of kit like on the left, circa probably 98. Is that Windows 98? Yeah. Oh, Windows 95. That's good. And you say to yourself, well, I've got this code. It's taken forever to run on my laptop, which has, a gig of RAM and a slow hard drive. I'm going to move it to the cloud. And then you find out, okay, you start asking questions. Why is my Python job only running 20% faster? The problem is, and you'll see here on the next slide, I'll flip back, is that this incredible genius, John von Neumann, designed our computer architecture over 70 years ago. And in this classical world of computing, where storage lives separately from computing, you end up in today's modern era being I/O bound, okay? And what does that mean? Again, this is pro tips for the analysts in the room. You are being constrained by the speed at which data can get to the brain of your device. The actual processor in that laptop may only be 30% slower than the fastest Amazon EC2 instance, the X1, which is my favorite. But in truth, you're pulling data off a hard drive. The hard drive is going to be slow. Doesn't matter what you do. So for us, as we do these kinds of things, we're thinking about how can we improve speed. And in this case, it's about I/O. So parallel Python won't get you there. Splitting files won't get you there. Hadoop could be, but ultimately you end up being NIC bound. The reason why I bring this up, this is more of the meat in the sandwich part, is you need to think more broadly about the tools you use and oftentimes help to define the architecture so that the tools you have at the airport to run your code are not just designed for all of the pilots, but they're designed for you to get a good experience out of the execution, okay? Good compute experience. So now, here's a couple pro tips. RAM disks, I/O is the enemy. Use Redis, split files, and parallelize, okay? I promise life will be better. Now, the second part I'm a little bit passionate about. I hate databases. My team knows this about me. I hate them from a certain company in particular, and I will not name that name because it could be a sponsor, Corona, and I don't want to get you in trouble. I really want to say the name, and I'm not going to. So they are, to me, slow, monolithic, expensive. They run 24/7. They require people to tune them. They require all of us to work in this horrible language called SQL. We're dealing with Edwin Codd's normalization from the 1970s, and it was all great when it started, but time has just passed it by. And so I focused a little bit on the cost, and I produced. Actually, we didn't produce the next graphic, but I threatened to so many times that my team will recognize this immediately. This is Patrick. He would work here with us, but you chose a database in designing your application. Patrick hopes you like your database, okay? For us, this is a reality, that some of the databases that we've chosen in our solutions are 50, 75,000 euro a year when you consider the server, the license, and all of the sort of overhead that goes along with it. Which would you rather do? Add another person to your organization or keep something like this running 24/7? Right? That for us has been an important thing to work through. And I'll give you an example of where a database and KVS solution kind of came together. So we have a whole bunch of clients, I've vastly simplified this, who have us map where their business happened. So one of the things, you see some different fields here across the top, and they're basically saying, well, last year Atlanta was part of the South region, now it's part of the Southeast. Can you remap that and give us some insight into our sales trends? Sure, we can do that. But we have these maps changing constantly. Now, this is the kind of thing, as you're taking in 100 million records, you say, okay, I'll create a lookup table like this by clients, and I'll just hit it. It's doable in SQL. It makes all the sense in the world, except that you're running 100 million records past it every day. You're going to have huge latency issues that will kill you. So for us, it was important that we put these into a schema. But we faced this and said, SQL's just not going to cut it. Converting this to key value stores allowed us to scale this out and use Hadoop and do this very, very quickly without any of the bother. And then frankly, going back to the ephemeral, the servers go away. There is no database that's standing up and holding this forever. You shut it down. Cost is zero. So we'll move on to another, again, this is back to the meat of the sandwich, guys, ETL to CDC. So ETL is the process by which you bring data in. Change data control is a process by which you look only at the stuff that changed. For us, a real simple solution, we had initially 50 databases that all would get combined once a month, and it would take us 3 weeks to sort through and figure out what happened. Massive jumbo base that cost me a lot. And instead, we use CDC and a little bit of key value stores to change that. We said, let's hash every record as it comes in. Let's look and see, have we seen this before? If we have, throw it away. If we haven't, now let's put that in a much, much smaller file, and we can deal with that and see what's changed. We can also look at what we were expecting to get but didn't get, which is an important integrity check. And so this whole process, thanks to the team here, has dropped us from 3 weeks to about 7 minutes. And liberated some of the brightest minds in the center to go spend time on the things that they love. Persistent versus ephemeral. If you look at Netflix, and I would take down this address here, if you're thinking about what kind of technology you should ultimately be aiming for 5 years down the road, Netflix probably released it last year. They are that far ahead of everybody else. They don't have a single server that stays up 24/7. They bring all of their servers up on a Friday night as we're settling in for, the next show that you want to watch, and they scale them all down here locally as you get into the wee hours of the morning. We're trying to do the exact same thing, and for us, the cost is simple. I mean, if you can take something and just have it run work hours, great. That's 40 hours a week instead of 168. If you're rolling things out around the globe, can you ask users if they're willing to wait a minute or two for us to spin up the servers? Can we actually keep them in an idle state, but then spin things up automatically? So for us, again, in the pro tips here, AWS Lambda, really worth looking at. Allows you to just fire up jobs on demand. Docker for us, and containerization and orchestration frameworks are pretty essential in that. Then the last thing I'll say is, for us, this has represented the biggest cultural change in terms of how we work. We were very much a waterfall organization 2 years ago plus. So we would get a scope. We would say, yep, we're going to do that part, but we have no idea when, and we have no idea what resources it'll take. So we'll throw more people at it along the way. Going to the Agile triangle has been hard. Now we have the whole center running Agile Scrum for a year. Every single thing we do, marketing, HR, everything falls into the Agile triangle. And it does require a leap of faith. I recently took 5 of our top analysts and said, we've got a meeting coming up, a big senior meeting in 5 weeks. What can you do for me on the machine learning side with a particular problem that had been vexing us for a while? And for me as a leader, I had to say, I'm not going to ask. I'm not going to force them to commit on scope. I have to be the one who shuts his mouth and says, we're going to put 5 people on this for 5 weeks, and we're going to hope to get something great. Well, we did. And the act of trusting the team to get there has inspired them, I'm certain, because what they delivered was jaw-dropping. A year ago, that would have been a very, very hard thing for us to do. There'd be a lot of nail-biting. I would have probably been, kept on a chain away from the team, not to bother them and see how they're doing. But for us now to really respect the professionalism, they're working in this integrated way. They're working across that airport of complexity, and we have total faith in how they deliver. So once you see the future, I think, the stack that we leave behind just feels very old to us. It feels very 2012-ish, of code and laptops and ETL and databases and persistent hardware and anything other than Agile. And for us, over the past year, we have moved faster and faster and faster, thanks to this combination that, again, we're working on. Love to hear your thoughts and feedback on how we could do it better, but this combination of making our analytics applications environmentally data aware, moving to cloud, moving to CDC, key value stores, ephemeral, agile, Scrum. This for us has been fantastic. Thank you. Thanks, everybody.